general form and nth term of a geometric progression. So, here in this topic we are going to discuss about the general form of a geometric progression and as well as the nth term of it, that is GP. So, geometric progression. So, we are going to frame the general form of a geometric progression and as well as the nth term of the GP, that is geometric progression. So, here generally it is denoted by GP. So, we are going to discuss these two topics under advanced level. So, here generally the first term of a sequence is denoted by means of the letter small a, and the common ratio of the sequence, that is GP, is denoted by means of the small letter, that is R. So, here first of all let the first term of GP be A, that is geometric progression be A, and at the same time, so you are going to assume the common ratio that is to be multiplied in order to get the remaining terms is R. So, we are going to assume the common ratio as R. So, here therefore, the first term is of A, except this first term the remaining terms T2, T3 and so on up to Tn. So, if n terms are arranged in case of this geometric progression, or in other words this geometric progression consists, if this sequence which is in geometric progression consists of n terms in it, the first term is of A, then the remaining terms will be obtained by means of multiplying the common ratio, that is R. So, here in order to get the second term, so here T2 can be obtained by means of multiplying the preceding term. So, the preceding term of T2, that is the second term's preceding term is of T1, that is the first term. It must be multiplied with its common ratio. So, here we have assumed the common ratio as R. So, here we have to multiply the preceding term, that is T1 of the T2 by multiplying with it R. So, here that implies, so here R into the first term. So, here we have assumed the first term as A. So, T1 is equals to A, T1 must be replaced by means of A. So, in this manner I got R into A, or we can write it as AR. So, in this manner I got, so here T2 the second term as AR. The first term is of A and the second term is of AR. In order to obtain the third term, so here third term is obtained by means of multiplying the same common ratio which is preceding term. So, the preceding term of T3, third term's preceding term will be of T2. So, here common ratio, that is R, must be multiplied with its preceding term. So, here just before to this third term will be of T2, which is the preceding term, which is called the preceding term. So, it must be multiplied with this preceding term, that is T2. So, that implies, so R into T2, but here T2 we got it as AR. So, here instead of T2 I am going to replace T2 by means of this AR. So, here A into R. So, that implies, so here A is written as it is, but here R raised to the power of 1 and here also R raised to the power of 1. So, here the exponents are of 1 and 1 each, the bases are equal here into in between as per the product rule. So, here A power m into A power n. So, that is the product rule is of A power m into A power n is equals to A power m plus n. According to this product rule, we can write the logical step as, so here the bases are of same, R and R, exponents must be added up as like here m plus n. So, here R to the power of 1 plus 1 is of 2. So, in this manner I got, so the third term, so T3 as A R to the power of 2, that is AR square. Then now in order to obtain the next term, that is fourth term, So here fourth term can be obtained by means of multiplying the same constant, that is the common term. So here constant, that is the common term is of, the common ratio is of r, must be multiplied with its preceding term. So preceding to T4 is of T3. So here that implies, so here r into T3. So here we got it as the T3 is of, so here T3 is of AR square. So here AR square AR square. So here r to the power of 2 and r to the power of 1 here. So that implies, so here bases are equal. So we have to add up the exponents. So here exponents are of 1 and as well as 2. So here bases are equal. The exponents must be added up. 1 plus 2 is of 3. So r to the power of 3. So in this manner I got, so T4. So T4, the fourth term is equals to AR to the power of 3. Then now, in order to get the fifth term, so fifth term can be obtained by means of multiplying the common ratio, that is r, with its preceding term. T5, the preceding term is of T4. So that implies, so here r must be multiplied with its preceding T4. So here T4 is equals to AR to the power of 3. So here that implies, so here r to the power of 3 and here r to the power of 1. So a must be written as it is, since there is a product in between r power 1 and r power 3. So here a power n into a power n. So here bases are same, the exponents must be added up. So 1 plus 3 is of 4, that is r to the power of 4. So in this manner I got T5 is equals to AR to the power of 4. So similarly, so this is the symbol of similarly. So here a T10, the 10th term can be obtained by means of multiplying r. So here T5 is equals to AR to the power of 4. So here it is 1 less, so that can be written as, so that implies AR to the power of, so here 5. So here it is of 4. So here 5 minus 1 is equals to, so it is of T5, 5 minus 1 is of 4. So we can write it as AR to the power of 5 minus 1. So here r to the power of 5 minus 1 is of 4. So here also we can write it as, so here a r to the power of, so we have to get the 10th term. So in order to get the 10th term, we have to subtract 1 from the T10. The order is of T10. So here from 10 minus 1, that is 9. So r to the power of 9 will be the 10th term. So here, so that implies a r to the power of 10 minus 1 is of 9. So here, if the sequence consists n terms, then the nth term, so here nth term, so it can be obtained by means of a r to the power of, so here you have to subtract 1 from the order is of n, so here n minus 1. So in this manner we will be getting the nth term as a r to the power of n minus 1. Then hence the sequence will be hence the gen form or the general form of geometric progression is the first term. So T1 is of the first term is of a, the second term is of AR, the third term is of AR square, is of a, the second term is of AR, the third term is of AR square, the fourth term is of AR cube, the fifth term is of AR to the power of 4, then dash dash, the nth term will be of AR to the power of n minus 1. If this sequence consists of n terms in it, then the nth term will be of AR to the power of n minus 1. So here therefore, so this is the sequence or this is the general form of the geometric progression. Then now so here in this case, so here the gen form of geometric progression is AR square, AR cube, AR to the power of 4 dash dash, and here the nth term will be of AR to the power of n minus 1. In this case, the first term, so here T1 is of A, the second term is of AR, the third term is of AR square, and the fourth term is of AR to the power of 4, fifth term is of AR to the power of 5, and nth term will be of AR to the power of n minus 1. So here in which first term, that is T1 is equals to A, and the common ratio, so here the common ratio is denoted by the letter R, that is equals to the formula is of the ratio of the two consecutive terms. The consecutive terms are of T1 and T2. The ratio will be of T2 by T1 or T3 by T2 or T4 by T2. The ratio of the term with its preceding. So here that is equals to T2. So here the T2, the second term is of AR divided by the first term. The first term is of A. So here A and A gets cancelled. So that is equals to R. The common ratio is of R. Then the nth term. So here hence the nth term of geometric progression is AR to the power of n minus 1. So here the nth term is denoted by means of Tn. So Tn is equals to AR to the power of n minus 1.